Hello everybody, we shall continue with the design of RCC T-beam bridges. We have given the basic principle and we have come to that one, that how now we shall distribute that your say vehicle load among all the girders, that which girder will take how much load, that we shall it will take, that we shall show. So, this is our that your say lecture number 19. Lecture number 19, this particular one we are showing here, that we would like to say that lecture number 19, that we shall continue, and then let me show you that we shall show you that one here. So, we shall come back to here, that we shall say regarding IRC class A loading, that as we have decided so this is the one that we have continued in the last class, and then now we have that loading whatever we have shown you, that is from IRC 6, that particular loading we have considered. This is the one that IRC class A loading, that particular loading we are having, and then this, since this is double lane. So, this double lane loading, that means we can keep side by side two class A loading that we can keep. Coming to this one here, this is the loading I have taken from IRC 6 here itself, that which I have shown earlier also. The loading whatever we are having here, all those things detail are there. That means, here we are having 4 wheels side by side, 2 wheels for one vehicle, another 2 wheels for the other vehicle that we shall have. And for each of them, the impression of that, this is the one we say we should know this information, that F, how much will be the F from the curve, what will be the corresponding W, what is the G between that. So, G is very important here, that we would like to find out how much will be the G. That means, here from outer to outer wheel, not center to center wheel. Please note this one, whereas we have this one actually center to center. This one whenever you are providing here, this particular one, that is center to center. So, we get this one from center to center, we get it, that is 1.8 meter. So, one information we have, that is 1.8 meter of the same vehicle between center to center wheels, that what Kuron we can say, that your says in the cross direction, this is 1.8. There is another one, we call it actually your say transverse longitudinal direction you can consider. So, that means, this section PP whatever you are considering here, this is the section we are getting it here. So, 1.8, and this side we are getting different values whatever actually given here, 3.2, 1.1 like that, all those things are given. So, that means, this is one cross section, you are looking this vehicle from side and you are looking this one from this direction, traffic direction, and that one we can consider here, that how much we can get that load. So, coming to this one here, now we are having axle load 11.4, 6.5, 2.7. For these different cases, we can find out 250 by 500, 200 by 380, 150 by 200. So, we are having here 2.7, 11.4, 6.8. So, this particular one here. So, we are having different impression. So, that means, here we can say that if we have this one, say I am going in the traffic direction, this is the impression of one wheel, this is the impression of another wheel, and this distance is supposed to be G, and then we are having this one will have different values. So, how much will be that for different cases you are having, this is 250 by 500, 200 by 380, 150 by 200. So, this value will be different for different loading. So, that means, along the vehicle you are having different actual impulses. So, that means the center to center we can have. So, obviously, in that case we can consider that load, that particular one will be different for that particular one will be here. So, what we shall do it here then in this case, then obviously we shall take it from the maximum one we can consider, and on the basis of that we shall find out the G. That means, this G we shall give it for the maximum load then. So, then for other cases it will be little more, okay, no problem. So, that particular one we can consider here. So, our thing is that for 5.3 meter to 6.1 meter, that one we are having. So, 0.4 meter, that is the one, and then up to 6.1 meter, gradually it will go up to 1.2. For our case it is more than 6.1 meter, that is 7.5 meter. So, we are getting this one 1.2 meter. That means, we shall get this G 1.2 meter, that is the one we can say. That means, in our case for single lane only you can say it will come gradually whatever we are having that value, but even then single lane also 5.3 meter, it will be less than that. So, that means, you can consider 0.4 meter single lane, and for double lane we shall consider 1.2 meter, that particular one we can consider. Now, another value is there F, and this F equal to 150 millimeter. So, we are getting these cases, we are getting F equal to 150 millimeter, that we are getting it here, and G equal to, let me write down that one here, 1200 millimeter. So, what I can do actually here, considering that aspect, I can take it here, this loading I can take it, that which is given here 11.4 ton. So, 250 by 500. So, I can take this one say as a 500. So, that means, here center to center of wheel of two vehicles in cross direction or transverse direction, not in longitudinal or traffic direction, it is in cross direction. So, this is the one, that traffic direction, the vehicles are moving like this. So, coming to this particular point here, then I can say, let us say the term, let us say GCC, I can say center to center, I can say will be equal to then 1200 plus 2 into 500 by 2. So, that I can have no other vehicle will have that particular one. So, which is coming as 1700 millimeter. So, GCC, that way I can say 1700 millimeter. So, this is the thing that we are getting it here, that particular one, that information is required, that particular one here. So, this particular one we are getting it here. Now, this is the loading for class A, whatever loading we have here, that loading IRC class A loading. So, I have given that one in kilonewton, and these all that dimension are given in millimeter. So, from the front wheel in IRC code, that is given from left to right, I have given that one, that means the traffic direction is in this direction, that way I mean to say. So, this one given. So, 27 like that, all in kilonewton, and that one from the front wheel, center of front wheel to the center of rear wheel, that one 18,800 millimeter. And just let me show you this particular one, we are getting it here. So, this is the one dimension we are getting here, and 20, that one we just see the difference, this particular one center to center. So, those things you should keep it in your mind, and 18.5 also, that one also you should keep in your mind, that one how much you are getting that. So, this is the loading that we are having, and this loading for the whole that one say vehicles, that particular one we are getting it here. So, that means here according to the IRC 6, the combination of that, either I can have 70R loading only one, because for double lane we should have, actually for double lane we should have two one IRC 70 loading, but for double length that we shall have, this is the one we are having here, that loading, that is for one IRCA loading, this is IRCA loading. So, how much is this one from this curve, and that one is your value f, which I have told you earlier, just to tell you this particular value f, that means this is the one from the end, this one, and this we are talking that f equal to 150 mm. So, you can come as close as the 6 inches, that means here that 150 millimeter means, see this particular one almost you can say, that means you can come very close, that is the one. Whereas, in your say IRC 70 loading you are having, that is 1.2 meter. So, it is quite far, but whereas in this particular one here it will come very close to that curve or footpath, that is the one you can find out. This is the basic difference here. Now, so we can find out this distance, this one is how much, this is of the same vehicle which is coming as 1.8 meter, this is coming as 1.7 meter, then you are coming as 1.8 meter. So, that means this loading, whenever we are providing this loading, that loading comes here, and P1, P2, P3, P4, that one we shall consider here, that how much will be that. Let us consider this one as G1 from the left, let us consider this one G1, let us consider G2, let us consider G3, let us consider this one G4. So, there are 4 girders. So, how much this girder P1 will take, that this one will take P1, how it will be distributed, P2 how it will be distributed, P3 how it will be distributed, P4 how it will be distributed, that we have to find out. As I have told you earlier, this one also now you can do the grid analysis, that you can make the grid of that one say of beams, and then you can find out directly applying the load, you can find out that your that different sections, how much is the bending moment, how much is the shear force, that you can find out. But here the method we are telling this particular, this is a very old method, but still it is relevant and useful, and this one gives you insight that how much that a girder actually, that placing the load, how much it will take. Obviously, that you can say P1 will be taken more by this girder this way, that you can find out here, and which comes similar fashion also. But whenever you are doing in the computer program, that one software you are using, sometimes it appears that you cannot, you are not feeling that how the loads are coming, how the loads are distributed, that way actually we miss that. Now, the thing is that here, as I have told you, 2.7 ton, that means 13.5 kilometer on one part here, another one here, this is 13.5, this is 13.5, that we can consider. That means the load is coming along the line, there are 2 vehicles, so it will come in that particular fashion. Next one we are taking say 34, that is 6.8 or 68 kilonewton. So, I can distribute here like that. So, that means so along the line cross direction we are having so many wheels, 4 wheels that are Kuron here, and those wheels load we have to distribute, that is our objective here. Similarly, other one also we can have, that means I can say if P is the load for one set of wheel in a one along one line. So, it will take P by 2 and this one will take P by 2, this one will take P by 2, this one will P by 2. So, I can say P is how much, if we can say, on the basis of that we can find out here. So, our objective is that this particular one, whenever we are coming to that one say P1, P2, P3, P4, that way you are getting it here. So, that one we use that one, there are many methods are there, but this is the most popular method, that Kuron's method of load distribution, that is the one we do it. And then we find out here that one, the objective is that if this load is P here, from the center line it is at a distance say E, then how that load P will be distributed along the all the girders, that is our objective. For that, according to Kuron's method, the reaction Ri of the cross beam of any girder I of a typical bridge consisting of multiple parallel beams is computed assuming a linear variation of deflection in the transverse direction. This is our assumption. The deflection will be maximum on the exterior girder on the side of the eccentric load, and reaction Ri equal to P by II sigma II plus P II by sigma II into E di sigma I by sigma I di square, or if I take it P II sigma I, therefore, if we take it. So, 1 plus sigma I by sigma I di square E di that way. Now, if II is equal, then the problem will become very simple, that if obviously most of the cases we consider that girder your say that second moment area same for all of them. So, in that case what will happen, that II by that what Kuron, that it will become actually P by N. If there are N girders, so I can consider this one 4I and this is I. So, on the basis of that we can find out the load that we can check it here. That is the whole idea, that you can find out and you can do it. This particular problem we can solve it here. Coming to this one here, and then what it says, that P total live load, II moment of inertia of girder, E eccentricity of the live load, distance of girder I from the axis of the bridge. So, that particular one you will get it here. So, what you will do actually here from this particular one here, whatever we have done, just let me tell you that figure. So, this loading whenever we are considering here along the girder, so we are having certain loading here, say 27 kilonewton. This is the loading class. Then we are having say little far away 114. Please allow me to not to write kilonewton again, assume that all kilonewton. Then we are having 68, 68, 68 and 68, maybe outside, maybe inside, depending on the span of the bridge. You are getting this is one load and another side by side another load. So, this 27 kilonewton whatever it is there. So, we shall get the corresponding load here, the similar load we shall get it, but on the basis of distribution we shall get another load we shall get it, because this P by 2, that means here we are having 1 wheel, 2 wheel, 3 wheel, 4 wheel, this is the plan. Another set you are getting here. If we look from the top, this one I am getting here, this one, so this is the line of 27 kilonewton. This is line another 27, this is another 114, that means here we are getting here 13.5, 13.5, 13.5 like that. So, this corresponding load for each girder I shall find a new value, and that means this 27 kilonewton, that one will be replaced along the girder. If I consider that is a simply supported beam, along the girder I shall get the new value of that, we shall find out, and on the basis of that we have to find out that bending moment and shear force, and when we shall get that particular one, then we can solve that, we can design it. So, our objective is that we shall find out on the basis of your bending moment shear force. Now, coming to this one here, that according to, just let me tell you, IRC that yours is 6, you shall get the combination of load. It is not simple say 1.5, somewhere it is 1.35, 1.5, that multiplication factor like that. So, then we have to apply that one, and then we shall get the bending moment and shear force, we shall get it here. So, this is the thing that we do it here, and just to tell you here, one is that I have told you that this is working stress method, where we are having sigma CBC, sigma ST. We are having this one say limit state method, we are having two methods we are having available. This value is according to that, though it is 4/9. So, let me write down here 0.45 FCK, and this is your x, this is also x. Now, in IRC there are this method also you can use it. Further, very interesting thing is there, we consider this one as 0.45 FCK, but this one we consider 0.8x. The force developed here due to this is your say limit state method, that collapse flexure. This is we are talking say your 0.87 Fy IRC 112. Now, what we are basically doing here, the area of this one actually you can say 0.36 FCK. This particular one we consider here, then we consider here say something say XU by D BD, like that we find out here that force or FC. The interesting part is that we are having that parabola and rectangular portion. So, we call it this stress, this is triangular stress, triangular stress block. This one we call it parabolic rectangular block, and this one we call it rectangular block. The interesting part is that what we do it here 0.8x, so 0.36, so this area 0.36. So, here if you just do it 0.8x, then you will get the same area. That means, you are reducing this factor on here, that means, so that I can get a rectangular block. What is the advantage of rectangular block? The advantage of rectangular block, for your rectangular section there is no such problem, but whenever you are having, for this case you are having T beam. So, in this case, to find out that your say bending moment or that compressive force, it is very easier to do it. Wherever you are having that your neutral axis, it does not matter, but here the neutral axis position dependent on that, because rectangular portion whether it will fall within the flange or not, on the basis of that your compressive force will be different, your neutral axis position will also be there, that your lever arm also will change. But in this case, that portion actually overcome using this particular one here, and this one also true for, I would like to say, that is also true for in Euro code also. They have followed that one, rather IRC code they have actually that followed that Euro code, it appears like that. Only thing that in Euro code I can say that they give actually your cylinder strength also, that I shall say that cylinder strength and cube strength that they give, but in our code we only follow cube strength. This is IRC and it is true for IRC 112 and it is true for IRC IS 456 also. We use this particular one and this is for Eurocode. There are different kind of volume, all those things. So, it is very easy to then find out, that means here that I can find out this portion and this portion, this one say whole thing will come and this portion whatever it will come, that immediately I can find out, and that. So, if I say this one is taken F1 and this one is taken say F2. So, this particular one I can immediately find out that one, just simple multiplication that we can do it and we can solve this problem. This is the one that we make it here, that your in this code we follow this particular one here. So, that means our objective is that I have told you that all the 3 methods on page we can get this one here, then we can take the other one another method, but the thing is that here if you are interested, the code also says that particular one you can go ahead with this one also, you can do it, or alternatively you can go this way, that particular one which is same like that, like the Eurocode only, that particular one you can do it. And this way you will find out the problem actually very simple, that particular one here. So, we shall give this problem, that one we shall give you as a that complete solution that we shall give you, so that you can go ahead with that. So, this is the thing that I could say, that one that we can find. One more thing actually I should say now, as I have told you that one more thing, that you have to design the cross beam also. If we have only one here cross beam, what we can do here, this particular case, in addition to that portion whatever I have told you, that one I can consider this one as I say one concentrated load also I can consider here, and then if there are 2 more cross beams here and here, then also we shall take it, and then on the basis of that we can find out. That means, this one here we are taking one by one all those things, that means independently we are considering each of them, we are considering, that is the outer girder and inner girder. Now, we can provide the same section for outer girder and inner girder, only thing we shall make it that we shall not provide the reinforcement, we shall change, that we shall not give the same. That means, maybe the inner girder will have that one kind of reinforcement, outer girder will have another kind of reinforcement. That way we can actually go ahead, because the thing is that that will be the better idea, that one the section, because your bearing other things are very important there. So, overall depth we shall keep it same, but inside that your reinforcement only we shall modify that, and that way it will be easier from the construction point of view. Because from the design, because I personally go for a simple design, because that if you would like to save actually that your say reinforcement and other kind of different kind of actually your say geometry, there is a possibility of doing mistake actually at site. So, that one the objective is that whenever the finally that your whole calculation whatever you will do, that nothing will go to site, only that drawing will go to the site. So, I shall tell you something regarding reinforcement in the next class, I shall tell you that, so that you can get an idea what exactly we want to do. So, main objective I personally feel that your drawing should be such that after looking the drawing immediately one can remember those values, that is more important, rather than every time you will go to drawings and check whether the dimensions are correct or not, whether the reinforcement are giving because many variations of reinforcement will prone to make actually your say that detailing problem at site. And then if you use the drawing more number of times more and more, then obviously the drawing will be that it will be actually that it will not in the proper shape immediately, because at site you are having dust other things. So, those things actually you have to keep it in your mind. The design should be as simple as possible. Another one I would like to say, this is not my comment, I got it this information that particular one from a very big person, that structural engineering or civil engineering structures is such that main thing that one, that if you look at the your say structure and if you feel that it is unsafe, and definitely it is unsafe. So, you should have that confidence in your that looking the structures you should have confidence. So, that is why from geometry point of view, that overall depth of the section, other geometry, all those things whenever we consider, in that case we find out that the section should be such that do not be miser, that only saving few millimeters other things, all those things, and you are making the structure actually unsafe. As I have told you, that one moment of resistance, that is more important here, and that one, that for concrete it will be always more than the steel, and for steel it will be always more than demand whatever that your requirement from the applied load point of view. So, with this I conclude this one today, that one. So, then we are having one more module, and we shall discuss a little bit about your say reinforcement, and then we shall close our this course. Thank you very much.